Good afternoon. I'm Kendall Reed with Cold Quanta. And there we go. We can move on to the next one, please. So Cold Quanta was founded in 2007 to commercialize enabling quantum technologies, and specifically cold and ultra-cold matter generation, in particular Bose-Einstein condensates, or BECs. And at the time, some folks were really laughing at that idea. BECs were the stuff of Nobel Prize-winning physics, not commercial products. And of course, they were correct. On the left here, you see the Ketterle BEC system from 1995. All those little bitty pieces are optical components. And BEC systems remained largely that complex for the next 15 years. But then one of our founders, Dr. Dana Anderson at CU, decided he wanted to come up with a transportable BEC system. And in the center, you can see one of our very earliest transportable BEC systems that Cold Quanta sold in 2013. And we still sell those now, and they are transportable. But today, Cold Quanta is working on developing truly OEM-style cold atom systems. And on the far right, you can see one of our monolithic cold atom generators. We do generate cold atoms in that, and within 2 years, we will take that little item, package it with the lasers and electronics and other supporting items it needs into a unit the size of a shoebox, coming down from that optical table there that's huge. So we have a shoebox full of cold atoms. So what's that do for us? Well, the applications depend on the environment around us affecting those atoms and how we manipulate and probe them. But, and if we can move on, regardless of what our application is, our quantum box remains largely the same. And you see the little bitty ones over on the side there. There's some different variations of it. But all of those employ Cold Quanta's IP that's protected via patents and trade secrets in subjects spanning ultra-high vacuum, optical fabrication, laser physics. And at this time, Cold Quanta is looking to find OEM partners to incorporate our quantum device into their packaged solution for timekeeping, navigation, secure communications, and computing. If you consider autonomous flight as an example, with quantum secured communications up and down, atomic navigation for guidance in GPS-denied environments, and atomic timekeeping for data synchronization and guidance, all of these applications can be addressed with our quantum box of cold atoms. So we do have, at this time, a successful commercial business selling products into the research market, and now we're poised to enter the industrial market just as quantum really takes off. Our safety and the safety of our data and our troops will be increasingly dependent on quantum technologies over the next decade, and Cold Quanta's OEM quantum box will be at the heart of solutions for all of these problems. Thank you.
Hi, so my name is Jacob Meyer. I'm here to talk to you about ATSP. Well, I'd like to define first what that stands for. That is aromatic thermosetting copolyester. So what we have done is we've developed a new general purpose ultra high temperature polymer, and we have the expertise and facilities to design it from a linear to a fully thermoset network. What that enables is basically a lot of tailorability, both in terms of function and in terms of access to process and final form factor. So one of the things you might ask is, why would you want to do this? Well, the reason you would want to do this is because actually that structure is fundamentally a very high temperature structure. Okay? It is a fully aromatic structure, and basically its upper temperature limits are somewhere going to be above 300 C in terms of, depending on case to case for what application you're talking about. Next slide, please. So ATSP has a very unique mix of properties. First off, it has extreme thermal performance, including glass transition temperatures over 300 C in some cases. High mechanical properties, competitive with basically all the performance polymers that you know and probably use. High electronic properties, including dielectric breakdown strengths that are superior to polyimides. Very low outgassing, again, superior to polyimides and PEEK and bismuthimides and so on and so forth, as well as extremely high wear resistance and low coefficient of friction. It has ablative characteristics, that is, it uses more energy to char than it does then it releases. So we have access to a lot of diverse form factors, as you saw earlier. It has a lot of novel processing and recyclability potential. And finally, it has very low production cost. And the final thing I would like to add is that it has access to what we call self-bond. So next slide. So what self-bond is basically it's a relatively new adhesive concept. And what this is essentially, if you imagine that you have a large arbitrary surface coated with our polymer, okay, at an elevated temperature and under some pressure, what will happen is that you will enable bond exchange reactions. And so these bond exchange reactions allow you essentially to use it as an adhesive in the fully solid state. Essentially, you just apply heat and pressure of any sort, basically, however you want it to get there. Basically, at that point, you will have a fully consolidated part, and additionally, the temperature use on it includes ranges up to 380 C. Now, the other interesting thing about this is that it is completely rebondable, as in you can break it, put it back together, and break it again as many times as you like. Okay? So, in fact, we did that over 50 cycles during our phase 1. Okay? And that's all while maintaining structural numbers at very high temperature. So, we also have access to extremely fast bonding times, including times down to 15 seconds, actually. And we would also add that you can think of it as basically a highly wear-resistant, non-tacky, indefinite adhesive that whenever you want it, you have applied it as paint, and at some later point in the future, you can always basically just add something else to it. So actually there's a lot of potential for additive manufacturing along those lines. There we go.
Can I ask you a question?